Hey, you guys. In this section, we're going to be talking about equations and inequalities involving absolute value. So let's get started. All right, so our objectives in this section are to solve equations involving absolute value as well as solve inequalities involving absolute value. So the first thing we're going to look at is the absolute value property. Okay, so I'm sure you guys have probably seen it, but let's just review it anyway. So what we know is if the absolute value of A equals B, where B is greater than or equal to 0, then either A equals negative B or A equals B. Now I know that sounds really complicated, but you guys have probably seen absolute value. And the one thing that we know about absolute value, no matter what the number is, once you put it inside of an absolute value, it comes out positive. So if I were to say the absolute value of negative 5, that value equals positive 5. If I said the absolute value of positive 5, that is still positive 5. Now, the reason why that occurs is because the absolute value is concerned with the distance a number is away from 0, but it does not take into account the direction. So if this were to be positive 3 and negative 3, if we took the absolute value of both of those numbers, they would both be 3. The reason for that is positive 3 is still 3 places from 0, and negative 3 is still 3 places from 0. When we are saying that a number is positive, we are saying that it's moved so many spaces to the right of 0. And when we say that a number is negative, we're saying that a number is so many spaces to the left of 0. But absolute value doesn't take into account the direction, which is why it's always positive. So the reason why understanding that is important is because when we get to absolute value equations like this one, the absolute value of 2x minus 1 equals 5, you're going to end up with two answers. So because every time you plug in a value into an absolute value, it comes out positive, you have to account for the negative answers as well. So when we're solving, what we're going to do, in order to drop the absolute value bars, you're going to have to always set your equation equal to its negative and its positive answer. Okay. Now, when you do this, notice that whatever was in the absolute value to start with did not change signs. The only thing we did was drop the absolute value bars. So the answer on the outside, we set it equal to its negative and its positive. Okay. Another thing to notice is that before we do this, the absolute value has to be isolated on one side of the equation. What that means is that there's nothing on the outside of this absolute value before you drop the absolute value bars and set it equal to its negative and its positive answer. Okay? So don't worry, we're going to do some examples. Okay. As we progress throughout the semester, you're going to see this word a lot, theorem. Okay? So what exactly is a theorem? Well, a theorem is a proven mathematical statement. Okay? So a theorem, whatever it tells you, is true under the conditions in which it's given. All right? So you'll notice that in the PowerPoint slides and in your book, the theorems will be numbered. The numbers don't make a difference. It's just a reference of how you can find them easily. So for example, the first theorem in section 5.2 just means that that's the first one that they mention in that particular section. Okay? All right, so our first theorem in this section says, if A is a positive real number and if U is any algebraic expression, then the absolute value of U equals A is equivalent to U equals A or U equals negative A. Okay, now this is exactly what I just explained to you, except now that it's formally written. So one thing I want you to do is get in the habit of seeing things formally written. So all it's saying is that if you have the absolute value of some expression equals A, and the absolute value is isolated, then in order for you to solve it, you can drop the absolute value bars and create two separate equations, U equals positive A and U equals negative A. Okay? So anytime you're solving an absolute value equation, you are going to get two different answers. So keep that in mind. All right, let's work through some examples. So our problem says to solve the equations, and A says the absolute value of x plus 4 equals 13. So we're going to start there. So first I'm going to write our problem. Okay? So the first step is to make sure that our absolute value is isolated. It is. There is nothing on the left-hand side of the equation that's on the outside of the absolute value bars. The 4 on the inside is fine because it's inside. Okay? Now, we're going to drop the absolute value bars. When we do, we're going to set the expression equal to its negative answer and its positive answer. Notice when we do this, whatever was in the absolute value bars stayed exactly the way that it was. Okay? Now, we're going to solve the equation like normal. So the goal is to get x by itself. So we're going to subtract 4 from both sides of the equation. So we have x equals negative 17 and x equals 9. So we have two answers. So sometimes they will have you list your answers, and anytime you do that, you list them from smallest to greatest. So we would say x equals negative 17 and 9. Okay? All right, let's try the second one. So we're going to write our problem. The absolute value of 2x minus 3 plus 2 equals 7. Okay? So our first step is to isolate the absolute value. So that means we're going to get it by itself. So this 2 that's on the outside of this absolute value on the left-hand side, it has to move. So in order to move it, we're going to subtract 2 from both sides. So we're going to have the absolute value of 2x minus 3 equals 5. Okay. Now that the absolute value is isolated, we can drop the absolute value bars and create two separate equations. So I'm going to have 2x minus 3 equals negative 5, and 2x minus 3 equals positive 5. All right, and we're going to solve them. So I need x by itself, so I'm going to add 3 to both sides. And then I'm going to divide both sides by 2. So x equals negative 1. I'm going to do the same thing to the other equation. So x equals 4. So for this problem, I have two answers. X equals negative 1 and x equals 4. Cool. All right, now, anytime you're solving these absolute value equations, you're going to follow those same steps. But I want you to be careful if you ever run into something like this. So let's say you have an absolute value, and it's x plus 2 equals negative 6, okay? Now, we just said that an absolute value cannot equal a negative number. It has to equal something positive. So if you ever get a situation where you have an absolute value and it equals a negative number, you can automatically say no solution, okay? Be careful. An absolute value cannot equal a negative number. We never got a negative number until after we dropped the absolute value bars. So just be careful. I don't want them to catch you. All right, cool.